Reject.
Hello? Hi. Hi, thank you very much for the warm introduction. I wasn't sure, or, ignoring the email for 2 weeks. And it wasn't 2 months, it was 2 weeks. I let it, I didn't reply to it, Things get tough. Hi, Reject.JS. Wow, this is the last talk. I'm so sorry. I'm the one in between fun and the tiring talk. I hope this is a little entertaining because a little bit of different thing. And I promise there will be JavaScript, but not much about JavaScript. So my name is Mariko. You might know me from this form of Twitter. That's my handle. That's my avatar currently. This is the first time I'm actually saying this in public. I do textile thing in JavaScript. And thank you. And it's funny that at the conference, people actually comes up to me saying that, oh, you are the knitting person. What do you actually do for a living? I'm a JS engineer at a company called Scripto, which is an awesome company who lets me decide my title completely based on my side project. Scripto is not a textile company. We make software for TV shows. And awesome company, very supportive. I get to spend 2 weeks here doing textile research and e-commuting to the company. So very grateful for that. So I'm also a co-organizer of Brooklyn.js, who was at the intro video for Jenna Zeigen. I have a B-roll video. We took that was past 11 p.m. after a full day of co-working and meetup, and we had a little drunk. We took maybe 4 takes, and there's a take of me rolling on the floor, just laughing entire time. So if you're interested, I can show you at the party. But Brooklyn.js looks like this. Woo! And what's really awesome is that in New York, not only Brooklyn.js, but we have Manhattan.js, Queen.js, JerseyScript. So if you visit New York, literally every week we have a JavaScript hangout. So just let me know when you're in town. We'll have a good time. So here's all the organizers of the Bolo.js family, we call it. And I am very, very proud of what we built in New York community. This year, we have 8 speakers coming into Reject.JS, CSS Conf, and JS Conf. So very proud of supportive network that we built. So what am I talking about today? I want to talk about CS. And you might think that oh, OK, CS, computer science. No, I don't want to talk about computer science. Computer science makes me sad and gray. I want to talk about craft science, that kind of CS. And the craft science looks like this. And this is something I've been doing for a few years, more avidly and extensively for the past few months, which is I do this intersection of coding and crafting, which mainly for myself, my project is a knitting. There is a little bit of background to why or how I came to this intersection. So I was a hand knitter first. I wasn't an engineer first. I learned to knit when I was 7. Maybe once a year, I make a little scarf. And it was something that wasn't serious hobby, but a light hobby that I do every year. 4 years ago, I moved to New York City. I didn't have a work visa, so I had nothing to do. And I was so bored enough to put myself into learning to code. I've been in tech industry for my career, and I was a PM, so I was comfortable with talking about techie stuff, but never got around actually learning to code. But I was bored enough to put myself into JavaScript tutorial. And doing that, I noticed that oh, JavaScript is actually helpful for my knitting. And I dug up the tweet that I remember that I tweeted about this, and it's in Japanese, so you can't really read it. Maybe some of you can. But it's saying that oh, I needed this counter for a project that I'm doing to keep track of how many rows that I knit. I learned JavaScript, so in 30 minutes, I used the browser and DOM, and that was super useful, fun. That's 2013. 8 months before I get a job as a JavaScript engineer. So when I'm doing knitting and the JavaScript, learning JavaScript, I noticed there's a correlation between knitting and coding. And knitting is very binary process, much like programming is ones and zeros. Atomic unit for knitting is 2 stitches, the type of stitches, knit stitch and purl stitch. And you can see there that there is 2 distinct face of the fabric that they produce. So if you have a sweater, you can just look at the pattern of it. It is a combination of knit or purl stitches, in here represented as a K or P. So the 2x2 living, that's all sometimes used in the cuff of your sweater or neckline, is 2 knit stitches, 2 purl stitches. And the one on the left is a little more intricate pattern, but if you just closely look at it, it is the alternate KP, KP, slightly shifting to the left. On top of that, the instruction of how to make scarf or how to make sweater comes in this form. And to me, it looks a lot like code. There is like repeating letters and maybe some kind of variables. There is like more explicit loop happening, like knit until 2 stitches remaining, or repeat from start to the end. So that means you can knit in JavaScript, because knitting is code. So let's take a look at this pattern. So the first line says CO5, and let's just do it in JavaScript. So CO means cast on, and that means that just create a space so that you can start. It's not a stitch yet. So it's kind of like you're creating empty LA, but like a length of 5, and casting on. So next line is K5, and K stands for knit stitch, and 5 means how many times you need to do it. So that means this line is saying like knit 5 stitches. So I created the variable K with letter capital K, and replaced a low 0 with 5 Ks in it. Voila, you put it into my scarf parent array, and now you knit it 1 row in JavaScript. The second line gets a little tricky. So the thing about knitting is that the loop is on the needle. So the previous array, the length of the previous array always inherited to the next row. Like you can't start the 5 stitches and then next row be 100 stitches. Well, technically there is a way to do it, but like a little more complicated. So you inherit the length from the previous row, create a new array, and then from there you count how many stitches and what to do. So the first one we already know. K2 means knit 2 stitches. So I put knit stitches, count up the index. So now you have 2 stitches in your array. Next one is a new concept, M1, which is make 1 stitches. And it's a lot like operating the splice method on your array and putting in like another element into your array. So like, pass the index where you are, put the new stitches. Now the array is length of 6. And then here you have a loop. And it's saying that how many ever you have on your needles, just knit until last remaining 2 stitches. So in this case, you only put 1 stitches, but you do the while loop until the remaining stitches are 2. And next one, we already did that, like same thing, repeating. Make 1, now your length is 7, and then knit 2, now your second row is complete. Push it to my scarf array, and then now you have 2 arrays or 2 rows of knitted fabric there. So continuing doing that, it looks like this to create a triangle-shaped scarf. And what I always thought was that the knitting is like you are compiling your code or knitting pattern in your brain, interpreting it, and then executing the computation on your hand and needles so that the free yarn, the yarn ball, is a free memory, and then the fabric is allocated memory. Now, do you agree that the knitting is like coding? Yeah? Yeah? On top of that, when you're designing your own knitted fabric, it is a lot like math. Like calculator is your friend, you need a graph paper. Here I am deciding on the design of the slope of the armhole, and then trying to decide how to decrease it so that it comes naturally to my bust line. And you need to fit the patterns into certain fabric real estate. It's a lot turns into like a puzzle, because you don't want the nice piece of pattern to be ended on the side. You want it to be center. So I enjoy that. And I have a tendency that like if I like something, I just go do like that thing forever and like don't sleep and then go like deep, deep down there. So like I really wanted to investigate a lot of pattern making and a lot of knitting. I found, although hand knitting takes time, and then I found a machine called Knitting Machine, which lets me make fabric way faster than I hand knit. And this is me creating a scarf that I have in here. But it's basically a machine that lets me do my job faster. It is not a new thing. My machine is from 80s, and these machine has been around since 1500s. My machine turned out to be a electronet, which is a computer-operated machine that lets me send the data into the machine so that I can program the pattern. And I did a little bit of a project about taking a digital photo image, turning it into bitmap image, turning it into ones and zeros array, turning it into that file by bit shifting, and then printing out in my knitting machine. And I gave a talk about that at a JSConf US past May. And if you have any question or if you want to know more about how I did it, I'm happy to talk so later. But today, I want to talk about what came after that project. So my machine was the first one to have a computer-operated version. But the version before was using a thing called punch card. And I have it here. And in investigating how knitting machine works, I was super fascinated. First of all, this is fucking beautiful. And I was so fascinated that I can control the machine by just perforated paper punch card. And I, again, go down the rabbit hole of researching something. And I realized that punch cards are actually cool. It touches, at some point of history, it touches automation of the machine and computation of doing the math on the data, and then touches the communication. And all of three, which I consider a base of computer and internet and like what we deal with every day, punch card touched that in history. So a little bit of information. Let's talk about like what's automation. So in 1745, Jacques de Vaugerson was commissioned by French government to create an automated textile loom for local silk industry. And he was the first one. I mean, before that, there was like a concept of using a punch card to operate the machine, but he was the first one to make a fully automated loom operated by punch card. Didn't get picked up quite well until 1800 when Joseph Marie Jacquard picked up the project and then improved it and created this famous loom called Jacquard loom. Side note, it's interesting that the British textile industry was up and coming, so Napoleon spent money actually on the local business, the Lyon, and they got like increasing number of orders, so they need a machine to make those orders, and he was commissioned by a merchant in Lyon to create those machines. This is the Jacquard loom that I just took part of my research trip to a textile museum in Netherlands. This is how it works. It's feeding the punch card and then selecting the thread in the machine to create a textile pattern. And here's a GIF animation from fabulous animation from Victoria and Albert Museum. Basically, punch card gets pushed, rods are pushed or not pushed, and then the thread attached to that is picked up by. And then wait for it, it goes down there to show, yes, this is how pixels are selected. So this is another find from the Textile Museum. It is discussing mechanism of the Jacquard loom, but to me, it looks a lot like explaining how computer graphics and pixel works, and I was like so like fascinated by that when I found out. So that was just using punch card to operate a machine. Like, how about computation part? So Kosaka was the first one known to use the punch card as a data storage. And he was a statistician who wanted to do faster work on his research. He proposed this thing called linear homoscope. And basically, it is a shelf with a hole and data in it. He creates a pins, kind of like a query. He runs that pin over the shelf, and then if that pin matches with the hole, you find the data faster than going through by hand. Another one, Charles Babbage from England, he planned the famous machine analytical engine, which used punch card as a data input. And Charles Babbage was the one, the Ada Lovelace was exchanging a letter, which some of you may know that became first computer program. Lovelace made a beautiful, beautiful quote about this machine, saying the analytical engine weaves algebraic patterns just like a Jacquard loom weaves flowers and leaves. Like, great. back in United States, there was another attempt to use punch card for computation, which is by Herman Hollis in 1889. He created this machine called tabulating machine. It's basically a punch card sorter to sort out data faster. And it came out of a need from US Census. So US Census happens every 10 years. And the census in 1880 took 9 years to compile that data because they did not have any equipment. There was a lot of immigrants coming in. They did the hand compile of the data, and it took 9 years. So like by the time you get all the analysis done, another census was happening, and it was going to be a problem the next census. So he created the machine called tabulating machine. And here's a picture of a lady inputting the data into punch card. By the way, the tabulating machine company, through different acquisition, became what is known as IBM right now. And then now it all makes sense that the IBM machine, punch card, it all came from there. So the communications part also touches on the perforated paper or punch card. Before going to the punch card, there's like a little prehistory. 1864. There was a first telegraph service happening between Washington, D.C. and New York. It used the piano-like keyboard, and then 2 operators were sitting at the end operating the thing. And soon they realized that they need to have a standard communication way. So the Emile Baudot in France created this 5-bit, 1s and 0s system called Baudot system and adopted in France. But then in 1901, Donald Murray was the first one who introduced this use of perforated paper or punch card as a part of teletype. So what he introduced was that instead of like typing and sending the data immediately, just type it into the paper and then create the paper source so that the papers, like those rules, are queued up, and it doesn't. Basically, the process becomes non-linear, and you can queue up the data. He actually worked on the Baudot code and became what is known as International Telegraph Alphabet, which still used the 5-bit. So they needed like space to represent all the letters. And they introduced the idea of shifting, and that's why you have a shift key in your computer. So basically, they have figure and letters. And whenever the shift to letters signal happens, then after that, everything gets read as a letters. And then if you see the shift to figure signal happens, then after that, everything after that is read as a figure. Of course, if you talk about the encoding system, I have to mention ASCII, which is American Standard Code for Information Interchange. Somebody did not really think about diversity. Somebody thought 7-bit is enough letters to represent all the communication letter, which is not enough. But they use the 128 characters. But then computer happened. Like computers are 8-bit. And like whole another level of bits now available to you. And there was a lot of multiple standards. Like Nordic countries started making their own standards because they needed their own letters to be represented. A country like Japan, my home country, decided to do this weird thing called multi-byte encoding, which is very programmatic when you are dealing with Japanese computer program till this day. Then there was a effort called Unicode, Unique, Unified, Universal Encoding. And if any of you want to geek out about like how awesome UTF-spec is, like I'm more than happy to do that, but not going into today. So I was like, after this like whole research, I was like, wow, that was a lot of Wikipedia read. But then like punch card is like actually really cool. I want to make one. So I quickly prototyped it out of tinfoil and note card and jumper wires. Didn't really work out. So my part was that the jumper wire is a leader, so like kind of like moves through it and then lead it, but didn't really work. I went back to like original drawing of like how jacquardine was made, and then like sketched up how it's gonna get. Head down to my friend's wood shop, cut some wood, measure some things, poke some hole, put the contact sheet on it, and then hook it to Arduino, and then now that's there. So I have that machine here. And I wrote an interpreter. So basically, the machine itself is just reading the data, the 8-bit data. And then what to do with it afterwards, up to me as a computer programmer. So I created this demo site, electro.mechanical.computer. By the way, I'm so proud of my domain purchase. That was available. By the way, .computer space, wide open. You should check that. So I'm going into the demo site. And I have a punch card that's made. Put it onto the machine on the side. And let's see if sends. Yay! So that's exclamation mark. And this one, that's a letter I. Oh, I'm doing demo backwards. It was supposed to say hi. There we go. So I created two demos. One is leading the same array, the binary array, turn it into ASCII characters so you can see the letters. The other one is much like a Jacquard loom, trying to create a textile pattern. So a little bit about how this thing whole gets together. Each pins, the 8 pins are buttons. So I used the Johnny 5 and then created the 8 buttons. And each button has an event of hold or release. So every time the button gets hold, I use socket IO to emit the WebSocket to my server, and then same as a release. And every time that event emitted, I send the index of which pin was hold or released. On the server side, it's very simple. I always have a pattern 8 zeros, and then whenever a socket comes in, replace that index with 1, and then parse that data into ASCII characters. On the demo of the textile side, I use the same array to see if it's 0, create a 8 white canvas box, and then if it's 1, create a black canvas box. So after this exercise, I was like, I finally understand how code works and computer reads my code. This is super cool. I can create my own punch card language in whatever way. But then dealing with binary is not as friendly as you think. It's just like you are always looking at chart of binary to hex to octal. It's just not fun. Luckily, us JavaScript programmers have a way to do this in JavaScript and skip whole punch card and binary system, which is make your own parser. So this summer, I attended the program called School for Poetic Computation. And there, I attended the class by Telegraph Miller called Talking to Machines, Those Assholes. And it was basically a class about how to create your own domain-specific language and how to create a parser for it. So I use a library called Reject.JS, which is a parser generator for JavaScript. And they have nice interface for online editing. They have so basically, you create your own grammar in Peg's way, and then Peg compiles into generator, and then they have a little interactive tester to see if it works. So let's see, they have simple grammar defined, and then in here, they have white space defined. So what if I don't want any white space in my language that I'm designing? So I just get rid of that. Then now, the parser is yelling at that, I'm not expecting white space. There's white space. So I get rid of it. Then it will say parse successfully. So I did this exercise for my thing and created my own domain-specific language called 64 Stitches, and specifically in the purpose to teach programmers how knitters read knitting patterns. So the language itself is designed to look exactly like a knitting pattern. Instead of using K and P, I use underscore and asterisk to represent a white space and black space so that kind of being able to see it visually. So let's zoom in. So remember when we did the JavaScript knitting, cast on is how wide to start with it. So if I change that cast on 8 to 16, it's wider width. And then if I go to a weird one that's 4, then, oh, it's not the weird. It's 3. Completely changes the shape of the pattern. And then you can change that to be completely white low, or completely black low. notice that the until 32 stitches remaining, I specifically wrote those parsers so that the programming language that the user needs to use is a language that the knitting machine uses. So I made that, and I tweeted thinking that maybe 10 of my friends who's nerd about things would like it. And I never expected to get this much positive feedback. I was never like a popular JavaScript library programmer, so like I was like, wow, people are weird. People like weird stuff. But it was great. A lot of like London people started tweeting at me their screenshot of their code and the pattern because I made the online app to be interactive so that the pattern, the code itself always gets compiled every time the key up event happens and change the pattern. So I added the feature to for those to save the pattern, and here's some example. This user, I'm like particularly proud that my code or sample was clear enough that she used loop in her code. And a lot of people ended up using that as like a mini pixel art generator. So here's a cat. Here's a skull. And invaders. And of course, JS. Writing my own parser turned out to be great exercise in learning ideas in computer science that I never learned because I did not take computer science, which is abstraction. The writing grammar for the parser is basically like saying, like in English, you have like a noun and verb, and it has to go in a certain order. Same thing, like I have to define what cast on is, and I have to define what loop is, and then going into smaller chunk, smaller chunk, smaller chunk, and kind of like learn, oh, this is what abstraction people are talking about. I get it now. And also, I stopped being mad at the JavaScript console yelling at me on the error because I learned that writing a meaningful error for the parser is super hard. So now, like, undefined is not a function. I'm OK with that. So what's next? I have no idea. I really don't. I'm just like way into this punch card thing, and I want to create my own language, and now I don't know what comes next. Although I have a few ideas of what I want to do next. One, just fucking put the code on GitHub. I'm like the person who creates like empty GitHub repo saying like, this will be this project, and never puts the code in. And like I have no reservation of putting in closed source or anything. I'm just being lazy. So I'll do that. And then next one is like I want to make an app for knitters. So this year, I've had a great opportunity, a lot of opportunity to talk to people like you, techies, about like how knitting is like a code and how knitting can teach you computer science. But knitters themselves, who does not use my hack or my code, contribute a lot to what I do, which is creating patterns, creating instruction for knitting machines. So I want to make a tool for them so that they can put more into this research. And really, what I want to do is like explore the idea of like craft as a computer science. And I've never liked computer science until I did this project. And then now I really want to learn about what computer science is about. So hopefully, in past 30 minutes, I convinced you that this picture not only looks like a craft project, but looks like a computer science project to you. Here's a list of resources that I have my projects on. And the last one is the one that's empty repo. I will put the code in. I have a few samples that I made. All of the scarves are JavaScript powered. I made a D3 chart, put that SVG file into knitting pattern, and then knit it in the file that was created by JavaScript. And remember that my first slide that has a Reject.JS and kind of like a graph paper, I created a lace pattern for the Reject.JS scarf, which I don't know if you can see. Can you see the JS logo in here? Yeah? Yeah, so if you want to see that, happy to show it. And just because I am obligated, I have a Broken.js stickers if you want to come find me. Thank you very much.
Reject.